Hi, my name is David Yorkback, and I'm a student at North Carolina Central University in Durham. I recently worked on a project that evaluated water quality in High Rock Lake, which is located in Rowan and Davidson Counties in western North Carolina. The project was funded by the North Carolina Attorney General Environmental Enhancement Grant, and it had participation from three universities: Wake Forest, North Carolina A&T, and North Carolina Central University, as well as some public and private partners such as Yadkin Riverkeeper and TruWeather Solutions. My role in the project was analyzing and visualizing data sets, and this presentation focuses on one of those data sets, which is poultry CAFOs. Now, CAFO is an acronym, and it stands for Concentrated Animal Feeding Operations. And in North Carolina, poultry CAFOs are widespread, but frequently underreported in state and federal records because they are unregulated, as opposed to swine and cattle CAFOs, which require permits and are subject to inspection. This complicates efforts to assess their environmental and health impacts. This study explores the use of remote sensing techniques, aerial imagery, and machine learning to systematically identify the location and distribution of poultry CAFOs in the High Rock Lake watershed. And this image here shows the interior of a poultry CAFO. So you can see where all these chickens are. There's one person standing in the middle, and you can kind of see how packed in they are. And that will come up later in the presentation. These two maps of poultry CAFOs show the beginning and end result of this data analysis. Data was collected from the National Agriculture Imagery Program, NAIP, and it was run through a machine learning model. I used the data to create these maps in ArcGIS Pro. The map on the left, shown right here, excuse me, the map on the left contains 4,659 data points across the entire state of North Carolina. That's a pretty large data set. The map on the right is a kernel density map of only the visually confirmed data points contained within the High Rock Lake watershed. And because I'm a geography student, we always like to know where things are. You can see it on this zoomed in map on the right. If you look over here on the left, there's the High Rock Lake watershed boundary. And High Rock Lake is located down here in the lower right-hand corner of the watershed, or the southeast part of the watershed right there. Okay, in order to visually identify the poultry CAFOs from the NAIP imagery, I first had to know how to recognize them. Now, they can be detected by characteristic spatial features shown in these images. They're typically large, elongated buildings, often in pairs or multiple parallel rows, and they're usually gray or off-white in color. Now, so the first thing I did was I used the clip tool in ArcGIS Pro to clip the initial data set to the High Rock Lake watershed boundary. Now there were only 623 data points for me to work with. I created a new field in the attribute table and I called it checked. All the values began as null and are symbolized in red. As I visually checked each data point, I would add a value of either 1, displayed in green, to show a visually confirmed poultry CAFO, or 2, displayed in blue, to show something other than a poultry CAFO, or what I call the false positive. And anytime I had difficulty identifying a specific data point from the NAIP imagery, I employed Google Maps and used their Street View feature to either confirm or deny the data point. For example, one building turned out to be, or one data point turned out to be a public storage building. And after I finished visually confirming all the data points, there were no more red dots, only blues and greens. And we don't often get round numbers when doing scientific research, but it turned out there were exactly 100 blue data points or false positives, leaving 523 green data points, which represent the visually confirmed poultry CAFOs. Now, since I mentioned the false positives, I just wanted to talk about those for a minute. The machine learning model contained these errors, what I called the false positives. And when analyzing the NAIP imagery, these included a pair of bridges up here, a railway yard, some solar farms, and even a lumber yard. And you can see why the machine learning model could make these errors. If you remember the slide I showed about how to identify the poultry CAFOs, you can see especially these bridges. They have these elongated rectangular shape and the off-white color. They're parallel to each other, and so this just shows some examples of why the machine learning model would make these errors. Okay. So the next thing I did was I exported the visually confirmed poultry CAFOs to a new feature layer and added the High Rock Lake watershed boundary. And as I mentioned, 523 of the 623 data points were visually confirmed as poultry CAFOs, and that shows about an 84% accuracy rate for the machine learning model. And that's not bad. In the classroom, 84%, that's a solid B on a test or a project. But it also illustrates the point that it illustrates the importance, rather, of the need for manual visual verification of these data sets. We cannot rely on the machine learning model because it is not 100% accurate. So it is a very helpful tool, but again, we still need that manual visual verification. Now, this could have been our final map, but one reason to not have this be the final map is privacy concerns. Users would have the ability to zoom into each of these data points and potentially find the addresses for these CAFOs. Now, this study isn't looking to target individuals, but rather to show where the greatest concentrations of poultry CAFOs are located that could potentially impact High Rock Lake. So, to work around the privacy concerns, I created a kernel density map of the visually confirmed poultry CAFOs. Now, the density was calculated by area, specifically square feet. Now, if you remember that image I showed towards the beginning of how crowded those chickens are in the CAFO, there's typically one chicken per square foot in each CAFO. Not great for the chickens, but it was great for me for the study because I could just use an easy 1-to-1 ratio when I was doing my calculations. And now, when you see on this map, uh, if you look at the legend here, basically where there's nothing, that means there's no significant data, no significant clustering of those poultry CAFOs. But once you get into the purple, that's when you start to get significant clustering up into the reds, the oranges, and the yellows. You look at the map. So these are the places where we have our greatest concentrations of the poultry CAFOs. And these are the places that, potentially cause the most risk for as a pollutant source to get down into here into High Rock Lake. And for those who don't know, because this boundary is the watershed, and what a watershed is, it means every drop of rain that falls within this boundary, unless it's absorbed into the earth somehow, it ultimately is going to find its way into High Rock Lake. Okay. And the last thing I did was I uploaded that map, the kernel density map, into the High Rock Lake water quality dashboard. Now, this dashboard was created by some other students who worked on the project prior to me coming on board. So I added this into this potential pollutant sources tab on the dashboard, and it's there along with some other data sets. One shows aggregated data points for swine and cattle CAFOs. That's these yellow circles. So now you can kind of see where the poultry CAFOs are in relation to the cattle and swine CAFOs. And another data set shows wastewater discharge points. These are permitted wastewater discharge points, and that's what all these green triangles are here. So wastewater discharge points. And again, all of these are potential pollutant sources that could get down into High Rock Lake. So, and I just want to show my acknowledgments. These are some of the other students who had worked on the project prior to me coming on board. These are some of the PIs on the project and some of our other partners who worked on this. And I have my references here for the data sets. And we'll just wrap up with questions. Obviously, there's no questions in this video, but I gave this presentation a couple of times, and the main question that came up is why are poultry CAFOs not permitted when cattle and hog CAFOs are? Now, that wasn't part of my study, but I also was curious, so I did do a cursory literature review. And the main reason is that cattle and hog CAFOs produce what's considered wet litter or liquid waste. right? And so it's understood that that liquid waste can make its way into our waterways, especially during in North Carolina. We get hurricanes, heavy thunderstorms, just any heavy rains that might cause flooding. Then those swine lagoons, the waste in those swine lagoons is likely to spill over into nearby rivers, streams, and creeks, polluting our waterways. Now, poultry CAFOs are considered, they produce what's considered dry litter, not wet waste. They don't have those lagoons. So that's a big part of the reason they're just not permitted. While they're recognized as a potential airborne pollutant source, they're not recognized as a potential waterway pollutant source. Though there are studies out there that definitely argue that the waste from poultry CAFOs can, in fact, make its way into the waterways, but that would be for a completely different study. And the last thing I do want to say on this is I'm going to go back to one of my very first slides here. Apologies for giving the viewers whiplash. But right here, some further study that could be done on this research that would be interesting is you can see I did just the 623 data points in the High Rock Lake watershed. But somebody else, not me, because I'm done on this project, but somebody else could look at all 4,659 data points across the state of North Carolina and try to visually confirm those. And then it would be really interesting to see how that 84% accuracy rate holds up. Does it get better? Does it actually improve up into the 90%? Does it get worse? Is it only 60% accurate, or does it hold about the same? So I think that would be some interesting further study on this project. And I will wrap it up there. Thank you so much for listening.